Well, here we go with the solutions to number 8. Look at quadratic inequalities and the discriminant. So question 1, we're given a function. It's a quadratic function, and they tell us that k is a real constant. First part of the question says to find the discriminant in terms of k. So the discriminant is b squared minus 4ac. So we look at this quadratic up here and we can see that a is equal to 1, b, the coefficient of x, is equal to k plus 3 because that's what's in front of the x, and the constant c at the end is just k. So to get our 2 marks we just have to substitute into this. So b squared, so we've got k plus 3 squared minus 4 times 1 times k, and then I'm going to multiply it out, k plus 3, and always worth double bracketing it, that's 4k, and we get k squared plus 6k plus 9 minus 4k, whoops a daisy, there we go, plus 4k minus 4k even, and that all simplifies into k squared plus 2k plus 9. And that's our discriminant. Now part B, still about the discriminant here. Show that the discriminant of f of x can be expressed in the form k plus a squared plus b. That is basically code for complete the square. So we take this, we take our k squared plus 2k plus 9, because that is the discriminant, and we're going to complete the square. So to do that we're going to start by putting our k, and then we halve the coefficient of k, so it's plus 1 in brackets, and square it, and then we subtract the square of this term, so we subtract 1 squared, and it's always subtract, and it's always this term squared, and then we stick the 9 on, and we tidy that up. That gives us k plus 1 squared, and minus 1 squared is minus 1, so minus 1 plus 9 is plus 8, and that is our discriminant expressed in completed square form. Now, show that for all values of k, the equation f of x equals 0 has real roots. So this is the first part of it. What does this mean? Well, real roots. So we start by saying for real roots, the discriminant b squared minus 4ac has to be greater than or equal to 0. Because if it's negative, you take the square root of a negative number in the quadratic formula, and you can't do the square root of a negative number. But the discriminant b squared minus 4ac is actually equal to this thing here, k plus 1 squared plus 8. And when we look at this, you can see that the only thing that can change is the bit with k in it here, and k plus 1 squared has got to be greater than or equal to 0 for all values of k. And you can see that because you're squaring it. So whatever you put in for k, even if you put in a negative number or a decimal or a fraction, when you square it you're going to get a positive number out. And so we can finish off our argument now. We can say that therefore b squared minus 4ac is greater than or equal to 0, and the equation f of x has real roots. And that's question 1 done. On to question 2. bit of curve sketching now. So let's have a look. This curve has equation y equals x plus 1 times x plus 3 squared, and we're asked to sketch C. So when you're asked to sketch something, you're looking for several things. First of all, you want to have factorized form, which we've already got. And if we didn't have factorized form, we would try and factorize it. We also want expanded form or standard form. And that's going to be given by y is equal to x plus 1 times, and we're going to multiply these brackets out to give us x squared plus 6x plus 9. And then those two multiply out to give x cubed plus 7x squared plus 15x plus 9. By the way, I've cheated, I did this earlier. You would probably need an extra line in there. Now, that's useful because it's telling us the intercept on the y-axis. So now I'm in a position to be able to sketch my curve. So draw my axes, and don't be afraid to have several goes at this if you think it's gone wrong. Now, factorized form, that tells me my x-intercepts. So I've got an x-intercept at -1, and I've got an x-intercept at -3 as well. So that's my x-intercepts. Now my y-intercept, when x equals 0, then all this lot disappears and y equals 9. So I've got, let's put it a bit further up, somewhere up here, at 9. So now I'm just going to figure out the shape of it. Well, the shape of it really comes from here. It's a positive cubic. So that's this shape. And it goes in two places. Now, there's a repeated root here. So that means it looks like this. It comes down here, goes through there, comes up, touches it, that's your repeated root, and then heads on down. So there we go. Now, show that dy by dx is equal to 3x squared plus 14x plus 15. Well, we know that y equals x plus 1 brackets x plus 3 squared, and we multiplied out this out earlier to get x cubed plus 7x squared plus 15x plus 9, and that's the form you need it in if you're going to differentiate. So let's differentiate now. So we have 3x squared plus 7 times 2x plus 15, and then 9 disappears, which leaves us with 3x squared plus 14x plus 15, and we have shown it. It has been demonstrated. Now we're given some more information here. We're told that the point A has an x coordinate of -5 and it lies on C. So let's just have a little get a feel for that. And then it's asked us to find the equation of the tangent to C at A. So let's just get a feel for what that means in terms of our curve. So you can see that x coordinate -5, so it's going to be somewhere down here, and we're after the tangent, so we're going to have something with quite a steep gradient, and it's going to be a straight line. So let's see if we can work that out. Now we've got x equals 0, sorry, x equals -5. It's a good idea to start by working out what y is really, isn't it? So I'm going to use the factorized form here. So that is -5 plus 1, and then it's -5 plus 3 all squared, which gives us -4 times, and that gives us 2 squared. So So it gives us minus 16. Right, it's minus 2 squared, isn't it, actually? Let's just correct that. Okay, so we've got ourselves our point A, so A is equal to minus 5 minus 16. Now, the gradient of the tangent at A. Well, we've just worked out the gradient of the curve in the last part, so it's given by dy by dx, and it was 3 times x squared, so that's minus 5 squared, plus 14 times x, which is minus 5, plus 15. So just have a little think about what we've done. We want the gradient of the tangent, and the gradient of the tangent is the same as the gradient of the curve, and this is the gradient of the curve, so all we have to do is put in our minus 5 into here, and out comes the gradient of the curve, which is the same as the gradient of the tangent. And that's what I'm doing down here. And then when we evaluate that, it turns out to be equal to 20. Now, that means that y is equal to 20x plus c. So now we substitute our coordinate in to find out our c. So we end up with y, sorry, it's not y, is it? It's going to be minus 16. So we've got minus 16 is equal to 20 times minus 5 plus c. So that's minus 16 is equal to minus 100 plus c. So therefore c is equal to 84. And that means that y is equal to 20x plus 84. Now, on to part D. There's another point on C. Will these points never end? The tangents to C at A and B are parallel. So let's go back to the graph and see if we can figure out where it is. Okay, so we've got this tangent down here, and another parallel tangent. Well, it can't be on here, it's going to have to be on here somewhere. So somewhere on this bit of line, there is a parallel tangent. Now, the clue to this is the fact that the gradient there must also be 20. So there's got to be two places on C where the gradient's 20. So we can use our gradient function, so we know that the dy by dx is equal to 20. But we also know that dy by dx is 3x squared plus 14x plus 15, so that must equal 20. And then we rearrange it. And then we factorise it. So 3x minus 1, x plus 5. And then we've got the one we already knew, which was x could be minus 5, but they told us that bit. So the other one here must be 3x minus 1 equals 0, which means that x is equal to 1 divided by 3. So that's the x coordinate we're asked to find. Core 2, bit of binomial before we finish. So question 3, find the first three terms in ascending powers of x of the binomial expansion of this bad boy. Give each term in its simplest form. Alright, well this isn't as bad as it looks. So the first thing is we put our binomial coefficients, which you could do from Pascal's triangle, but to be honest, it's easier this way. So we use this bit here, and the first one is 5, choose 0, and then it's 3 to the power of 5, and bx to the power of 0. And the next term is 5, choose 1, and then it's going to be 3 to the power of 4, and bx to the power of 1. And then 5, choose 2, 3 to the power of 3, and bx to the power of 2. And I'm going to stop there because I've got my first three terms. and I'm going to evaluate them. 5 choose 0 is 1. 3 to the power of 5, my calculator says that's 243. And then we've got 5 choose 1, which is 5, times 3 to the power of 4, which is 81, times bx. And then 5 choose 2 is 10, and 3 to the power of 3 is 27, and bx squared is b squared x squared. So this simplifies to 243 plus 405 times bx plus 270 b squared x squared. And there we go. Now, given that in this expansion the coefficient of x squared is twice the coefficient of x, find the value of b. So the coefficient of x squared, well, that's the thing in front of x squared, and that's this bit. And the coefficient of x, well, that's the bit in front of x, that's that bit. So what they've given us here is an equation. So the coefficient of x squared, so 270 b squared, is twice, 2 times, the coefficient of x, which is 405b. And we can rearrange this. Now, I'm going to, because I've got a squared, as I've mentioned to many of you that I teach, you've got to be very careful you don't lose solutions. So I'm going to do what might seem a little bit long-winded to you, but I'm doing it this way just to show you that there is another solution. Now that's 810, isn't it? So minus 810 times b is equal to 0. So it's a quadratic, I've set it all over here. And now I'm going to factorise. And that gives me 270b minus 810 equals 0. So I've done it this way because you can clearly see that a possible solution is b equals 0, and you wouldn't want to lose that in many situations. Here, it doesn't really matter because we know that b is a non-zero constant, so we know that solution has been sort of rendered a non-solution by the sort of information they've given us. So it's this bit in here we're interested in. 270b minus 810 equals 0. So that means 270b equals 810, and so b is 810 divided by 270, which is 3. So b equals 3. If you don't believe it, you can check it. Very straightforward that, because all you have to do, we know the coefficient of x squared, well that's going to be 270 times 3 squared, and the coefficient of x is 405 times 3, because that's what b is. And if you work those out, you should find that this one is double the bottom one. You can try it yourselves. And there we go. Hope it's going well for you, and I'll see you soon.